great to be here again. So I'm going to talk about this concept called lenses, and it's a concept from functional programming. You can follow these slides, which are actually just a repository of a bunch of files, in that address if you want. So lenses, every time I mention it to people in a casual situation, they get a bit scared, like, whoa, that's like some very complex functional programming thing, right? And that's not true. But if I would teach lenses in a proper way, I would need to teach a bunch of concepts. So I'm not going to do that. I'm not going to teach functional programming. I'm going to teach the JavaScript functional programming, which is kind of looks like functional programming, yeah, but you get the point, okay? So to demystify things, basically a lens is the functional equivalent of getters and setters. So object-oriented programming has classes with getters and setters. That's useful. Functional programming also has something like that, and it's called lenses. But it doesn't actually mutate anything, because that's, functional programming typically doesn't do that. And it's also composable. We're going to see what that means. But this is essentially the idea. So if you want to use getters and setters in an immutable style, that's the point of lenses. So I stumbled upon lenses when I was building the state management library for Cycle.js called CycleState. And this was not my idea. Someone came with an issue saying, hey, it makes a lot of sense to have lenses here. And we discussed for a long time trying to figure out what's the best way. And we found a way of putting lenses in CycleState. And it's really good. I really like it. I'm super thankful that they started that thread. And really cannot state how much I like lenses in the state management tool. And it turns out that it's a simple concept that could be applied for other frameworks, such as React and with Redux, and Angular with NGRX and Vue. So these sort of approaches are typically what people use for state management, and I believe that you could use lenses for those, and I'm going to show some examples. Raise your hands if you're using something else than this for state management, something radically different. OK, I think there's like 3 hands or something like that among, I don't know, how many are we? More than 100. So yeah, probably you will find a way of using lenses if you're using one of these. OK, but before I talk about lenses, I just need to talk about functors and profunctors. And I know this is going to sound scary, but honestly, you already use functors. Example. Not yet example, but a functor is essentially whenever you need to map from something to another. Functors are mappables. So you need to convert from some kind of data form to another format. That's the use case for a functor. Example. I have a function. Let's say this function takes numbers and returns to me the name of those numbers in strings. And I can take an array of numbers, and I can map those using .map with that function, and I get a new array of strings. Right? You probably do this. It's very important that I don't mutate this array, but instead I'm creating a new one. And you can also have maps in different contexts. Like here, from Immutable.js, you can make a set of numbers, and you can map those set of numbers to get a set of strings. OK? This is probably familiar to you. This is a functor. These things, whenever you have something that can be mapped, that's essentially like a mappable. Here are other examples where you might find this concept of mapping. Let's say if you use RxJS, then there's this operator called map. Also maps from one thing to another, from A to B. In Vuex, you might map actions to some methods. In Redux, you might map the state and the store to some props. That's it. So profunctors are a special type of functor that they convert from A to B, just like functors do, but they also unconvert. So you have a way of converting from A to B, but also from B to A. And you don't often see profunctors literally in JavaScript, but you see use cases of profunctors. For instance, if you convert from an object to a string, or a string back to that object, this is conversion from back and forth, right? You can do that. You also have conversion from strings to dates, and from dates back to strings. So this is one of those use cases. Here's another use case that starts to be more useful for state management, is if you use React Redux, then there's this thing called connect. And connect takes two arguments: maps state to props and maps dispatch to props. You can think of this as, I have my store with state, I want to convert that to my component. And then the component might change something, emit some event, and then I want to convert that back to something meaningful in the store, right? So we kind of have a two-way conversion here where you want to do this back and forth. So is this a profunctor? Not really, but it's getting there. It's almost that. Okay, so if you've used this, you've kind of used the profunctor, but don't quote me on that. Okay, so what is a lens then? A lens is a special type of profunctor. It's a way of converting a state object from your store to another state object, but also back. That's essentially the use case for lenses in JavaScript. I can show an example. Let's say, you get some data from some API that's from America, and it has temperatures in Fahrenheit. That's wrong, right? That's silly, right? So let's do something better than that. Let's make the EU weather object, and we want the temperature to be in Celsius, right? But we can use getters for that. So this is not lenses yet. This is just getters and setters. You just do return. So I need to convert Fahrenheit to Celsius, and I just need to do US weather.temperature. I actually have that function ready here. I just need to import it from a utils file, Fahrenheit to Celsius, and then we're also going to need Celsius to Fahrenheit later. If you want to see this, it's not that hard. You just take Fahrenheit and do some calculation. Yeah, anyway. So this is how I can get the temperature in Celsius. And if I want to set a new Celsius temperature, then I just need to convert Celsius to Fahrenheit. Whoops, sorry. Like this. And then I need to update US weather.temp. Like that. And then I also need the wind. I'm just going to keep it in the same format that it was. It's not that important. I was just interested in converting Celsius. So I could then console log the US weather in Fahrenheit and the EU weather in Celsius. And now I can also change the EU weather temperature to be less hot, let's say way less hot. And then we can print that and see what happens. So it says 80 Fahrenheit and 27 Celsius, same thing. And then I decreased the temperature and became 63 Fahrenheit. So the point is that you might want to interact with Celsius, right? You might want to make calculations in Celsius. You don't care about doing that in Fahrenheit. So this getter setter gives you that conversion layer back and forth, but it's object-oriented programming. How would we use lenses, which are the functional programming style? So a lens is actually a very simple thing. It's just the functional alternative of this. So I would have a function called getter, and it will return the same thing as this did. But as you see, this is now coming from the closure. I'm sort of referencing something global, and that's not nice. I want to make a pure function that takes input and gives out the output. So I just need to make this a parameter. I'm going to call this object, okay? obj. That's it, right? That's the getter part. Now the setter part is basically I get the new Celsius, and I sort of mutate that global thing. No, that's not the functional way. The functional way is that we return something, right? So we should return a new object that has that temperature there converted Celsius to Fahrenheit, like this, right? But the problem here is that this object is now missing the wind, right? So I basically am missing some data there. So what I need to do is actually pass the previous weather object there and just object spread everything that it had before. So if I pass the old US weather, I will just use everything that was there, but I'm going to update the temperature field to be this new one. So how would I use that? Let's try getting, let's just console log US weather, and you apply the getter on it. Of course, this is going to give you the Celsius, like this. So it says 27. And then I also want to set it. I want to make it 10 degrees colder. I apply the setter. I say 17 on the previous object, which is US weather. And that will return the new US weather. And then I can console log that, and let's see what that does. It says 63 and wind. So here is what a lens is. This is a lens. It's two functions, a getter and a setter, with this kind of interface that it takes the new piece, the previous parent that you had, and it makes a new parent. That's it. This is lens. I'm not importing any library. It's not any fancy thing. But you could also use libraries if you want. One of the nice libraries for functional programming is called Ramda. And you don't really need Ramda, but it gives you some nice things. So for instance, one thing I could do is just bundle these two functions in a thing called lens. It's probably an object or something. I don't really care because Ramda takes care of that for me. So I'm just putting these two functions together in this thing called Ramda lens. And then there's a slightly similar API of using this. We just say Ramda view under this lens the US weather. And I promise you that this is essentially, no, it is the same thing as calling getter on US weather. It is the same thing. It kind of seems like more code to write, but it's going to make sense soon when we compose things. So, and the setter here, this code would be the same thing as r.set. Here I pass the lens, the new value, and the US weather. I think that works. So these two, yeah, this does the same thing as before. But now Ramda gives you a few helpers. You could actually split this into two parts. So one of the things is that there's the object and then object temperature. That's one of the operations that I want to do. So I'm going to make another lens here called pick temperature lens. And it is, I'm going to get the object and just pick the temperature, right? And then when I have a new temperature, I want to put that back into the object. I just object spread that and pass the new temperature. This is it. This is the pick temperature lens. And then I can make another lens called Celsius lens, which does conversion from Fahrenheit to Celsius. So I do Fahrenheit to Celsius, Celsius to Fahrenheit. Easy. And so I'm just splitting these. As you see, I had the same thing before, object to object temperature, Fahrenheit to Celsius, so that we can write a sort of composition of these two. And this is the nice thing of functional programming, is that you can split these operations, and you can just, just like you can do array.map, map, map, map. Same kind of thing here. We're doing, different kind of levels here. So I'm just using this lens to operate on that weather data. And it does the same thing. Boring, right? Yeah, someone is even yawning. So let's make this a bit more interesting. So this is what happened. I had my weather data from the United States. It was wrong. We had to fix it. So we passed it through these. We viewed that data through a certain perspective, right? We applied get and then get again. We got 27. We can update this data on this side, and it will unconvert it back to 80, and then it will fit that back into that object, create a new object in an immutable way. This is lens, right? And you can see why they called it lens, because you kind of have some physical object and you're viewing it through some lens, right? That's the idea. So how could you use this for state management? I made some simple web apps here, like this. The code behind there is in Cycle.js. I'm also going to show other frameworks. So Cycle.js has, the state management library, and there's 3 components here. There's the top-level app, and there's 2 thermometers. So I can change the global state through the American thermometer, make it hotter, because that's what Americans do to the climate. And the Europeans can just reduce the climate, and then they just keep on doing this kind of stuff over the many decades in the future. Let's see how that goes. But the interesting thing is that they're operating on the same global state, right? Yeah, so how does this look like in practice? The EU thermometer, as you see, so source is essentially props, right? So I'm getting state from above in Celsius, I'm just displaying it on the DOM. And then when a click happens on one of these buttons, I'm going to essentially dispatch an update. I'm going to take the previous Celsius and return that -2. And you see, this component doesn't care about Fahrenheit. It thinks that everything that exists is Celsius. It doesn't even know about Fahrenheit, right? And then the US component is similar, but it thinks in Fahrenheit, and it doesn't even know about Celsius. So it's actually the parent's job to do that conversion back and forth. So it does that conversion for us. So for instance, here, the EU lens, as you see, it will take that global state object, pick the temperature, convert it to Fahrenheit, convert it to Celsius. And then once there's new Celsius, we're just going to fit that into the global state object, right? So I don't want to show you too much code here because I don't want to teach Cycle.js, but that's it, right? We had a simple app structure, these 3 components, but between this relationship of parent-child, we had lenses in between. The lenses did this conversion so that global app state got converted to a number in Celsius. The thermometer changes that number, sends an update, and that gets converted to a new parent object, which gets converted to also a number. I'm sorry, this is Celsius, this is Fahrenheit. And it's pretty simple, actually. Once you get the idea of this talk, it's very boring. So this is what's going on. We had the parent state, and we had this conversion layer. The format here is always this. So you always have the getter doing a conversion from parent state to child state, and the setter knows how to fit in the new child state back into the parent. So you have to have new child, old parent, new parent. And honestly, you've been doing this. Does anyone recognize what this looks like? You probably don't have the courage to say it, even though you recognize, but that's a selector. In Redux, in Vuex, in NGRX, you use selectors all over the place. Now, the missing piece was actually the unselectors. That was not in these frameworks. And it's very useful, because now we can do this immutable conversion layers back and forth, not just one way. So typically in Redux, what you have, and Vuex and NGRX, is that you have the selectors here in the component state, component tree, but you don't have the conversion back. Instead, what we do is that you dispatch an action, that gets combined in some reducer, the store updates, and then back again. So once I discovered this pattern in Cycle.js, I thought, why use globals in the first place? Why can't we just do this? Right? Honestly, why can't we just do this? It's simple, right? So, of course, people in all these framework communities thought about this problem a lot, and it turns out that there's a big reason why they didn't do this. It's that if you would do this conversion of data yourself, and this is what was written in the Vue docs, the simplicity, essentially, of having just the component state tree quickly breaks down when you have multiple components that share some common state, et cetera, et cetera. And essentially, the problem is that you could have pieces of data that need to be updated via events. So that was quite horrible. So what happened is that if you had some data in B1, let's say Celsius over there, and Fahrenheit over here, then once you change the Celsius, you need to send up an event, and this parent has to handle that event and send to that one, which has to send down here. And it was a lot of manual prop piping, what they called. But the problem, I think, is that it was manual, right? That was the problem. It's manual work. But what if it would be automatic? What if you could do this, but without the manual labor of synchronizing all the parts? What if they would just be automatically synchronized? So I think that's the use case for these lenses. So, for instance, here's a React app. It literally looks exactly the same thing, so I'm not going to demo. I mean, it does exactly the same thing. And we have there the parent component, the EU thermometer and the US thermometer. And I'm using something that I made called use profunctor state. It's a hook. And here's how the EU thermometer looks like. It will get some data, and it will just display that. And once a click happens, it will call the set state, which interestingly comes from above, and it will just change that. So when it calls set state, there will be some unselector doing the conversion back to the parent. So here's how it looks like, how the parent sets that up. Here's the EU lens, for instance. It picks the temperature, and then it converts that to Celsius, gives it to the child over here. And then the child changes that data, converts back to Fahrenheit, puts it back in, and it changes the global state. That's it. Here's an example in Vue.js. Actually, I managed to write this. It also looks exactly the same. It does the same thing, where we have these three components. The EU thermometer gets this state from above, so you just need to install this mixin. And then when a click happens, it will sort of mutate that. But this will also have a conversion layer backwards to the parent. And I made this library called Vue Lens Mixin. It's super simple. I don't recommend that you use it because I just built it 2 days ago. I'm sorry. Yeah, let's take a look at it, actually. Just so you see that these stuff are really not complicated. That's my library. 18 lines. Yeah, there's nothing complex here. So it works as a proof of concept. You probably just need to optimize it for performance. So here's how you would use it. The parents component would have to essentially define these lenses somehow. And again, they're just a pair of two functions. And then pass that to these child components. Those child components need to have the mixin installed, but that's it. After that, there's not much more. Okay, so lens for state management, I really like it. I really recommend it. What it gives you as a benefit is that each component thinks that it's working on local state. That's the nice thing. But in reality, that gets converted to global state. It gets combined all up, and it becomes one single global state that's serializable, that's immutable, and is functional. And fractal means that you don't have singletons, that you could, it's all hierarchical. There's less concepts to learn, and manage as well, like the reducers, the actions, the store, the dispatch. You don't need that kind of stuff. You only use your knowledge of selectors, and you learn one more thing called the unselectors, and now you know lenses. I already prepared some basic questions and answers because I think people quite often have basic questions, such as, well, no, sorry, that was wrong. I still want to talk about MobX a little bit. MobX actually has conversion back and forth because it has getters and setters, but it is the mutable style. So it's not immutable. We know that. But on the other hand, there is such thing called MobX state tree, right? And we know that that's under the hood really immutable. And it does have conversion back and forth in an immutable way. So is MobX state tree essentially the same thing as lenses? So I had this conversation with Michel yesterday, and it was a good conversation. He basically, I don't want to speak on his behalf, but he basically said that, yeah, these are very close to each other. Michel also wanted to make a lens library. Yeah, well, you could say that MobX state tree is quite close to lenses, conceptually. OK, now for the questions. I still want to have some local state. I don't want all of the local states to be combined to the parent state. Yeah, you can still have local state. That's no problem. Just an example in, let's say, Vue.js. So this came from above, and it will be combined with the parent back again. But you can always do this, for instance. You could define here some local state. Let's say return foo. And then you just render foo somewhere there. You can totally do that. And this will not be combined with the parent's state. So you could still have local state. Has this been used in a large app? Yes. If you follow the slides, you can take a link that takes to an app that I've been working on. And lenses are really nice there, really like it. And not just this kind of lenses, but lenses in general has been used in functional programming for a lot of years. And after all, it's just a very simple idea, so it's not like, a library that has some concerns that you might want to study. Yeah. How's the performance? So you have to be a bit careful when using functional programming to not do unnecessary calculations. Obviously, that's the case. In functional programming in general. In cycle state, the state management library, we did optimize it to not be so slow. In use profunctor state, I tried to follow the best practices for hooks, and I think it's fine. It's probably fine. I don't know for sure. In view lens mixin, as I said, it's just a small proof of concept, because what's very important is that each of these frameworks has a different way of propagating change, of updating and making sure that not updating things in vain. So I think the proper way of putting lenses in Vue would be using internal knowledge from the Vue framework and avoiding some unnecessary computations. Please make some lens library for Angular if you feel like. You could take these as reference if you want. And this looks kind of like two-way data binding. Some people thought about that. So no, this is not two-way data binding. I could explain how it's not, but I don't have the time. So if you really do think that this looks like two-way data binding, come talk to me. I can explain. So what is the catch? Is this just perfect? Of course, everything has some kind of catches. So for instance, here, with lenses, it's not always sure who is controlling a piece of state, right? It could be that the European thermometer actually wants to keep this at 31 always. But then there's something else that's changing, and there can be some competition going on. So it's just important that you, when designing things, sort of take consideration of, okay, this should be owned by that, should be not shared with that. It has to be some kind of careful design. You anyway have this problem with Redux as well, because global state has everything and everybody shares stuff. So yeah, the link is there. I just like to end it with this quote from Dan Abramov that Flux libraries are like glasses. You'll know when you need them, And I just want to add one small thing, is that glasses need lenses, right? Thank you.